computer. That is why it is known as a process virtual machine. It is not a system virtual machine. So that JVM that we use, so it uses the same architecture. It produces the bytecode. Bytecode is a platform independent code that can be used to run on any platform. So similarly, for when the ISA is same, we can just solve the virtualization problem there by using the multiprocessing system, multiprocessors. Like we know the multiprocessor concept, so by through that only we can solve the problem when the ISA is same. Now let's talk about when ISA is different. So when ISA is different, you will use high level language virtual manager, virtual machine, high level language virtual machine. So this is an simple architecture of how this high level language virtual machine works. So some high level program that we have a software in our computer that is written in a high level program. So for first of all, it will be compiled and then it will generate some portable code. So this portable code will be distributed to various virtual machine loaders, machine loaders, and then after creating those codes images, it will be converted into host instructions, and then our host machine's instruction will be carried out. Our that virtualizing software we are using, the virtual OS we are using, that instruction will be carried out. So this is what happens whenever the ISC is different. Now let's come to the second part, when the system virtual machine. So what is system virtual machine? Now we can directly see the diagram here. System virtual machine, we have the base layer, that is a hardware layer, and above that we have a virtualizing software. And here you can see that OS is not above hardware and virtualization software is completely taking up the hardware part. Above that we are using OS and application softwares. So this means we can use as many operating systems as we can with a single virtualizing software. And this virtualizing software, this uses all the resources directly from the hardware. So this is the architecture layer. So if we conclude this diagram that is in the left part and to the right part, we can see that we have just one system, that is system virtual machine, and above that we have just two layers, that is operating system and application layer. So this is what abstraction does. Abstraction means this virtualization software hardware, these parts are completely enclosed from the user to see all these things. User can just see that there is a system virtual machine and I am just sitting on the system virtual machine and operating on the OS. So this is how the architecture is designed, and with the help of abstraction, so these all things are hidden from the user. So system virtual machine. So also there are two challenges, that when the ISA is same, what will do when our ISA is same. So when our ISA is same, we have two things. We have two solutions, that is classical system virtual machine and hosted virtual machine. So what is classical system? Now here the VMM, that is virtual machine monitor or virtual machine manager, they runs on high privilege mode when it intercepts and emulates all guest OS actions. So what do I mean when it is highly privileged mode? Like you can see in this virtual software, they sit just above the hardware, so they will use every resource at a privileged mode. So that in classical system virtual machine, whenever we're trying to emulate any operating system, we can directly, our VMM can provide us resources instantly. Then we have hosted virtual machine. So what is hosted virtual machine? Now when we put a virtualization software to run on an existing operating software, it results hosted virtual machine. Means now you'll use a virtualization software that we have existing operating system, and then we'll use a virtualization software. Our virtualization software will completely not have any like full access to our hardware, that we will have existing software, and then we'll use a VMM, and then we'll install a operating system like some Macintosh or something. So that is known as hosted virtual machine. Means there will be there will be a host existed in our system. Now here the virtualization software can rely on the host operating system to provide device driver and other services rather than VMM. Now in hosted virtual machine, not the like in the classical system virtual machine, the VMM did all the jobs. The VMM provided the resource to the guest operating system and all. But in hosted virtual machine, these service provider, the job of service provider will be done by the host operating system, not the VMM. Now let's talk about the last part, that is when the ISA is different. So when we have the whole, now here we have also two solutions, that is whole system virtual machine and code design virtual machine. So what is whole system? It virtualizes all the software, which includes application software and OS. So what whole system does, whole system will virtualize the operating system and even the application software that resides in it. whole virtual system will means, as the name suggests, it will virtualize the whole environment. Let it be operating system, let it be application. It will virtualize everything. And since the ISA differ here, it simulates both the iOS and application software codes. So why it needs to emulate everything? Why does it needs to virtualize everything? Because the ISA differ here, so it has to generate the code for OS and application software code both. Now, for example, like we normally, what we do is a whole system virtual machine, that is an Windows OS running on Mac OS. Like when we have a Windows OS, then we have installed a Mac OS, and inside that Mac OS we are putting some other applications to run. So that is a whole system virtual machine. And here is the last part, that is the code design virtual machine. So these virtual machines implements new ISA which targets improving performance, power efficiency. Means these code design virtual machine, they will generate new ISAs. They will not try to convert it to any ISAs, or they will not try to anything fancy. They will just generate new ISAs that will improve the target machine's performance and power efficiency. Now here the host ISA may be different or extended version. Means like the Windows, let I'm using Windows as a host machine, and I have some ISA in it. So the virtualizing OS, or the guest OS that I have installed right now, that if that is a code design virtual machine, it will try to generate an ISA that will be a new kind of ISA which will directly communicate with the host machine, and it does not depend to converts its instruction or anything. Now how does it do that? It includes a binary translator that converts guest instruction into optimized sequence of host instructions and catches them in concealed memory region. Okay, this will be a bit of technical part, so let's skip that. And here the summary of everything. Like in a virtual machine, we have two virtual machines, that is process and vsystem. And when we have same ISA in process, we'll use multi-programmed system. That is, we don't have to use any VMMs, or you don't have to use any virtualizing software, anything. We'll just use our multi-processing, multi-programming ability of our operating system. And when we have different ISA, we'll be using high-level language VMs or dynamic translators. So both are same thing, high-level language virtual machines. And when we have system virtual machine, when we have same ISA, we'll be using classical system or hosted virtual machines. And when we have different ISA, we'll be using whole system or code design virtual machines. So that's all, sir. Thank you. Hello. Hello, sir. Hello, sir. Am I audible, everyone?
Yeah, Rishabh, go to the last slide. Rishabh.
Yes, sir.
Rishabh,
Yes, sir.
last slide दिखाओ तो कहाँ क्या? You are telling something, some component connector. You are telling something.
Yes, sir.
There is steps.
Always focus on component connector and the main part. If it is a layer, then talk about layer. If it is something else, for example, you may talk about shared memory for the interpreter. So talk about what is interpreter, how does it share, so, and what are the components, what are the connectors. These are the main area. You don't have to talk about the hardware or instruction or varieties of VM, and the architecture part. Focus on the architecture part. Okay. Okay. So what are the components? What are the connectors?
Yes, sir. Is the slide visible, sir?
Yes, yes, very, very.
Yes, sir.
Yeah, right.
Yes, sir. The components are the layers. The components in VMs are the layers offering a set of services to other layers, typically comprising several program subcomponents. That means within a layer we can have many of the several many components, subcomponents, or several subprograms in between within a component. So what is the component? Component itself a layer within a VM. There are various layers. So all those layers will act as a component, whereas the connectors are the typically procedure calls in the VM style. So we have studied all the types of connectors, that are 6 types of connectors. So we will use a procedure calls in this VM style. We will use procedure calls. So from a given layer, from a given connector, we will pass a procedure call to above its layer or below its layer, depending on the top down or bottom up approach of the style in the ordered layers. So we will try to communicate with other components through procedure calls. So now what procedures call can send? They can send data elements to other layers, so that they can work on those data elements. What are those data elements? They will be passed as parameters through the procedure calls to the components. So so the components are the layers. They will communicate with each other through connectors that are the procedure calls. What will procedure calls will send in between the components? They will send the data elements. What will be those data elements? They will be the parameters passed in between the layers, in between the components through connectors. That is the procedure calls. Now what is the configuration in the VM style? How the components will be arranged in the VM style? That is the layer. How the layers will be arranged in a strict VM style? They are arranged in linear form from top to bottom or bottom to up depending upon the architecture we use. So they will be in linear form. So a given layer will provide service to another layer, and then that layer will provide services to another layer, then that layer will provide services to another layer, and that will go on to hierarchical. Whereas in the non-strict VM style, we will use a directed acyclic graph. What is a directed acyclic graph? That in which there will be no cycles, so that if there will be no cycles, that means if a layer is providing services to another layer, then that layer can't provide service to the previous layer only. It will provide services to another layer. So there will be a cyclic graph that will not be a cyclic graph, and that will be directed. So this is the basic topology, the configuration in which the components will be arranged. The components will be the layer, the connectors will be the procedure calls, whereas the data element which will pass through the procedure calls will be the parameters passed along with the procedure calls to the components in between the layers. Yes, sir.
Okay. Okay. Thank you. Thank you. A good presentation. In future, you talk about the main theme of the software architecture, concentrating mostly on initially 1 or 2 slides on the basic, then jump to what are the components, what are the connectors, and how the configuration is maintained with some examples. Okay, with some examples. Give some examples so that it becomes more interesting. How the services are connected between layers. With some sort of example, then it becomes interesting for your friends. Okay, it is already 5:30. Let us close it down. We'll talk tomorrow. I think I have given another assignment, that is client server. Okay, client server to Shivam and Ranveer. So you must have prepared something. And
Sir,
yeah,
hello,
yeah,
sir.
Yes,
yeah.
Sir,
sir, we have
have
prepared only
combinedly
one
made one.
PPT together.
Uh, uh,
So
hello.
we have prepared, hello? Yes, sir.
Yes,
Hello?
yes, yes.
Yes, sir. So I was saying that we have combinedly prepared only one PPT, and we have divided the
You
PPT
divide,
slides.
among yourself.
Yes, sir.
Maximum
Yes,
Yes,
sir.
sir.
10,
We
12,
have
each
prepared one,
maximum 10,
yeah.
12. You divide, make it half. Okay,
Yes,
as
sir.
Yes, sir.
Half,
Yes.
half will be explained by me and
don't
half by
repeat
Shivam.
it. Okay, don't
Yeah,
repeat it.
yes, sir.
Discuss
Yes,
among yourself. Don't
yes,
repeat it. Maximum 10, 12 by Shivam, maximum 10, 12 by Ranveer. Because
yes,
time is
Yes,
running out. Time is running out. Okay,
yes, sir.
yes,
Yes.
sir. Yes.
so that it
Thank you,
becomes
sir.
more important. Talk about the architecture part, software architecture part from the layered point of view, and
Okay,
give some example at the end. Okay,
okay, sir.
example at the end so that it becomes more interesting. What happens in some layered architecture? Okay, okay, we'll close it down. But others, please ask some question. Go through what is a layered architecture, how virtual machine works, how client server works. Ask some good question from the architecture point of view. How the components you have missed. What are the components you should have told? You tell. He is waiting. Your friends are waiting to hear from you only. Not that one will tell, other will sleep. They have to make a note, because I will ask question. What is the instruction? A small question, 2 marks, 1 or 2 mark question will come from this virtual machine, from client server. 1 or 2 critical question will come. What are the components? What are the connectors in a virtual machine? So you have to note down and take interest to interact with your friend. Rishabh was waiting to answer you, so you should ask him some question. Okay? Next class you ask him. Okay? Okay. So we'll close down. So I want this type of participative teaching. You should participate so that you take interest in it. You come prepared, read it, then ask question to me or to Debabhaya or to who is presenting. Okay? Okay. So let us close it down. It is already 5:32. It's already 5:32. Let us close it down. Okay. Bye, students. Bye. Bye, students. Bye.
Bye, sir.
Bye. Take care of
Thank you,
your
sir.
health. Yeah. Take care of your health. Do gargling and inhaling in the night a must. Okay?